Hello, I'm going to do number 2 on the activity sheet, the one with the Mona Lisa. Pretty nice problem that covers, I think, everything you need to know. So we have a picture of the famous painting, right, Mona Lisa, in a book. It says the picture in the book is 1/5 as wide as the original painting, and it gives you the size of it, right? So the picture is 24 square inches. What is the area of the original painting? Okay, so lots of things to think about here. The imagery I get when I think of this is you could say maybe this is the one that is in the book. The original might look something like this, right? Much larger there. And so this is the key. It says my picture is 1/5 as wide. So I think it's safe to assume similarity, right? So also 1/5 as long. So if you're going in this direction, right, your length scale factor is 1/5, right? I think it's easier to think in this direction, right? So if you go from the small one to the large one, then the length scale factor is 5, right? So it's a little bit easier to envision that. So those are the basic things you're going to need to figure out this problem. All right, so let's look at the questions. Is it reasonable to assume that the pictures are similar? Absolutely, this is a yes, right? And the reason for that we saw, I think, on probably a couple of lessons ago. The reason for that is because otherwise the Mona Lisa will look warped, right? So it will look wider than the original or it will look too slim. So we're going to definitely assume that they're similar. So what is the length ratio, right? Large to small. They basically give us that in the problem, right? So there's a couple of different ways you can write this. So if it's large to small, right, this is one way you can express the ratio. That's the given one, 1 to 1/5. But it's also good to think about it without fractions, right? So you can think about it like that. So that's really saying that the large one, right, is 5 times the size, both in terms of length and width, right? So these two are equivalent. So this brings us back a couple of units when we were talking about ratios, right? These are really the same ratio that we're talking about. All right, so question C is where it really gets important, right? What is the area ratio large to small, right? So if we look back at the imagery, if this is really 5 times as tall and 5 times as wide, then very similar to that Santa painting problem, that means this small one here you can fit 5 times across, also 5 times on the vertical. So that means you can fit 25 of these little ones inside the original painting. So if we express it this way, you would get that, right? 1 to 25, or the other way of doing it, 25 to 1, right? So this is really saying that that smaller one is 1/25 the size if you think about area, right? So this is a simpler way of understanding it, right, with the 25 to 1 ratio. And then with this, you can do these calculations, right? So how big is the larger painting? So this goes back to, let's grab this one here. The length scale factor is 5. So if the length scale factor is 5, then we saw in that earlier video, the area scale factor is the length scale factor squared, right? So we can think of it this way. 5 times 5, that's not actually where all of this information comes from, right? So the area scale factor is 25, so that means you can take the old area, multiply it by 25, and you'll get the new one. And that's precisely what's being asked here. How big is the original painting? So we would have to take the number they give us, right? The 24 square inches, scale it by 25, and then you have your answer. Okay, so this is the picture in the book, 24 square inches. Multiply here by the area scale factor, which is the 25. What do we get here? 600. Okay, so 600 square inches. So that's the size of the original. So I'll mention just before stopping the video, The common mistake, as we saw in the Santa problem, is using 5 in the spot, right? So that'll give you the incorrect answer because you're only doing one of length or width. And here we have to do the times 5 in both directions. So it's okay if we think of that as 5 squared. Okay,